Organic compounds with double or triple bonds between carbon atoms are called unsaturated hydrocarbons. And it's these unsaturated hydrocarbons that undergo addition reactions. The second bond in a double bond is slightly weaker and can easily be broken. The reacting atoms then add to the carbons on either side of the original double bond. Addition reactions tend to happen relatively easily due to the reactivity of a double or a triple bond. The first reaction we're going to look at is the reaction between an alkene and hydrogen, and it's called hydrogenation. As we go through these reactions, make sure that you take careful note of the name of the reaction, the reactants that are required, and once again, the particular reaction conditions. During hydrogenation, the double bond breaks and a hydrogen atom is added on either side. Let's consider propene reacting with hydrogen. The double bond in the unsaturated alkene breaks and hydrogen is added on either side to give the saturated compound propane. The reaction requires a catalyst like platinum. If the alkene is a gas like propene, then it's simply passed over the platinum catalyst. If the alkene is a liquid, then it must be dissolved in a non-polar solvent. Hydrogenation is a really important industrial process. It's used to convert unsaturated liquid oils into saturated fats, and it's used in margarines. The second addition reaction is when an alkene reacts with a halogen. We call this halogenation. Here, the double bond breaks and a halogen atom is added on either side. If ethene reacts with chlorine, the double bond breaks, a chlorine atom is added on either side, and 1,2 dichloroethane is formed. This reaction proceeds easily at room temperature. Alkenes can also react with hydrogen halides, like hydrogen chloride or hydrogen bromide. Here the double bond breaks and the hydrogen atom is added on one side and the halogen is added on the other side. The reaction is called hydrogenation. If ethene reacts with hydrogen chloride, then the hydrogen atom attaches on the one side and the chlorine atom on the other side to form chloroethane. The only reaction condition here is that no water must be present, or else it too can react with the alkene. An interesting problem arises when we have an unsymmetrical alkene like propene. Can you see that two possible addition isomers can arise? 1-chloropropane and 2-chloropropane. And so which one is formed? In 1869, a Russian chemist called Vladimir Markovnikovs solved this problem, and he stated it in what we know today as Markovnikovs rule. It states that a hydrogen atom will add to the carbon atom that already has the greatest number of hydrogen atoms. So let's have a look at how that works with propene. When the double bond breaks, carbon number 1 has 2 hydrogens attached, and carbon number 2 has only 1. And so according to Markovnikovs rule, the hydrogen will attach to the carbon with the most hydrogens, and so it attaches to carbon number 1, and the chlorine attaches to carbon number 2. This gives us 2-chloropropane as the most common product. You can think of it like this. Hydrogen's a fun-loving atom. It loves to be with its friends, and so it always gathers to the carbon that has got the most other hydrogens attached to it. The third addition reaction is the reaction between an alkene and water. Here, the hydrogen attaches to the one side of the broken double bond, and the OH hydroxyl to the other side, giving us an alcohol as the product. The reaction is called a hydration reaction. If but-1-ene reacts with water, we again have an unsymmetrical alkene, and we'll need Markovnikovs rule. Carbon number 1 has 2 hydrogens, and carbon number 2 only 1. So the hydrogen then will attach to carbon number 1, and the OH group to carbon number 2, giving us a product of butan 2-ol. This reaction requires a strong acid catalyst, such as sulfuric or phosphoric acid. Addition reactions also occur in the production of polymers, but we're going to look at this polymerization reaction in much greater detail in a separate section. Finally, addition reactions are very useful for determining whether an unknown substance is unsaturated, in other words has double or triple bonds, or is saturated, in other words only has single bonds between the carbon atoms. The test works like this. An orange-brown solution of bromine water is added to the unknown. If the unknown substance is saturated, then no addition reaction takes place and the bromine water remains unreacted and orange-brown in color. If the unknown substance is unsaturated and contains a double or triple bond, then it will immediately react with the bromine water in a halogenation reaction. The orange-brown color of the bromine water will then disappear and a colorless solution will form. In summary then, if you add the bromine water to an unknown and it remains orange-brown in color, then that means that that unknown is saturated. If you add it and it changes color and becomes colorless, then you know that your unknown was unsaturated. Sure, there's quite a lot of information on this section on addition reactions. Make sure that you've got a careful set of notes, and I suggest you invest some time in studying those carefully.